In this video, we are going to talk about how we can come up with XOR gate and XNOR gate by using NOR gates. So let's start with XOR gate. Okay, let's just dive right into it. So we have two signals. Okay, and when we send it through an XOR gate, okay, what happens is if the odd number of signals, okay, if the odd number of signals are 1, then the output will be 1. Okay, so according to the truth table, I just want to go through the truth table because it will be helpful for me to explain what we are doing. So since there are two input signals, the combinations are 4, 0, 0, 1, 1 and 0, 1, 0, 1. Here, if the input signals are 1, but odd number of input signals are 1, then the output will be also 1. So here 0, here 1, and here 0. Okay. When we are working with NAND gates, not NOR gates, when we are working with NAND gates, it's better if you have the min terms. Okay, these terms, min terms are preferred. But when you're working with NOR gates, the max terms are preferred. Okay, POS is preferred. Obviously, it's not exactly standard POS since we have irregularities. The bar going over more than one single signal. Okay, this is the irregularity we are working with, but it's fine actually. Okay, since we are working with NOR gates. So since this is the max term, we know 0 is the term we are looking for. So this can be given as A plus B, and this one is given as A bar plus B bar. And this can be given as, okay, let's say Z is the output we are expecting. Well, Z is given as A XOR B, which can be written down as A plus B into A bar plus B bar. That's it. Okay, so this is what we have. But as we are working with NOR gates, we can't have a dot. Okay, and is like too much work when we are working with NOR gates. So we will use double negation to remove that dot. So that will give us, I'll just do step by step. So we will have the double negation first. So we will have A plus B whole thing bar into A bar plus B bar. And when I break only this bar by using the De Morgan's law, we are going to break bar. So it will be like this. A plus B whole thing bar plus, instead of into, we have to put plus A bar plus B bar. That's it. That's all you need to do. Why? Now it's settled. Why? Here we have A plus B whole thing bar, which is the NOR gate. Okay. Here we have A bar, which means we need a NOT gate, which can be developed by using NOR gate. And here we need B bar. Well, that's also another NOT gate. And then A bar plus B bar whole thing bar, which is another NOR gate. And then we have, here we have a signal, here we have a signal, including that we have a no gate. So we will have another NOT. Okay. So this is how you have to come up with how you can draw for XOR gate. Okay. Now you can draw the, you can come up with the logic circuit by using NOR gate easily. If you have this foundation, then it's easy. So let's have A and B, and then the signal lines. I really don't know what these mean, but I just call it as signal lines. Okay. Okay. First of all, A plus B whole thing bar. So that's not an issue. Why is it not an issue? Because that's a NOR gate. So we can directly use a NOR gate without any issues. So here we have A plus B whole thing bar. And then we need A bar. So how can we come up with A bar? Well, simple. Just send A twice through a single NOR gate. We have A bar here. Well, I'm not going to hold it here because we need to send it through another NOR gate. And then we need B bar. So I'll also do that for B also, so that I can come up with B bar. So this is done. If you have any doubts on how I am working with NOT gate, or how am I creating NOT gate by using NOR gate, please visit my last video where I have explained the basic gate. Okay, now this is done. And finally, we have to send these two signals through another NOR gate so that it works like a perfect XOR gate. Okay, so how many gates are we using? 5 gates. We are using 5 gates. Well, if you think of it like the other way, the sum of products way, how it will come, well, it is like A bar B plus we have A B bar. So here also we can do the same thing. Okay, here also we can do the same thing. But the thing is, instead of putting over both these things, okay, instead of using the double negation both these things, we'll use the double negation separately for these guys. Okay, so that will give us, I will get A double bar plus B bar whole thing bar, okay, plus A bar plus B double bar whole thing bar, and that can be reduced into a plus b bar plus a bar plus b whole thing bar. Okay, and well, what can we do now? Well, that's it. This is enough. And then since we have a OR gate here, we will need two NOR gates, and here we need a NOT gate, here we need a NOT gate. So there is a NOT gate here, there is a NOT gate here, and then finally we have another NOR gate for these two signals. So that is well, there are two more NOR gates required. So that will end up in 6 NOR gates. But here we have only 5 gates required. So we choose this instead of that. And if you want more explanation on this, please let me know in the comments. I will do a specific video for that. No worries. But I think you can try this on your own. What I'm trying to tell you. Okay, you can try this on your own. Now we will talk about XNOR gates. Okay, we can talk about XNOR gates. Well, XNOR gates can be given as the A XOR B, right? A XOR B whole thing bar. So you can either think of it like this: how A plus B into A bar plus B bar whole thing bar. You can either think of it like this, okay, which I don't encourage, okay, or you can think of it like this: A XOR B whole thing bar can be given as A bar plus B into A plus B bar. Why do I prefer this? Well, you can double negate this, and by using just 5 NOR gates, you can find the answer. Okay, for XNOR, you can come up with the logical circuit diagram. So you can try this on your own. Okay, try this on your own, and you will learn. This will be using 6 gates. Okay, if you rearrange this, you will get 6 gates. Please try this on your own. But now we are going to look at this method. Okay, we are going to look at this method. So I'm going to use the double negation first. So let's use the double negation, which will give us A bar plus B into A plus B bar whole thing double bar. And I'm going to break only this single bar, which will give me A bar plus B plus A bar plus B whole thing bar plus A plus B bar whole thing bar. And then we have another whole thing bar, including all these things. Okay, so that's what we have. Now I can draw without any issues. Okay, obviously I need a NOT gate here. I need a NOT gate here. Here we need a NOR gate. Here we need a NOR gate. And finally, here we need a NOR gate. So totally 5 gates are enough. Okay, so let me draw the signal lines first. So first of all, we need A bar. So let's run it through a NOR gate twice so that we get a NOT gate out of it. And then we need B coming together to go through a NOR gate. Okay, and that's done. Similarly, we need a B bar. That's not an issue. It's also possible. So we need a B bar. So we'll run the B twice, signal B twice into one NOR gate. And now we can pass it to this guy. And finally, these two signals will be sent through a single NOR gate. Okay, that's it. And you will have the output without any issues. Okay, so that's it for XNOR gate. Here you need 6 gates, and you can do the rearrangements in your own time. There is no issues. There is no rush in that. Okay, to do that when you have free time, and that's it. So in the next video, we will be looking at some example questions, how you can use NOR gates to come up with the expression. And that's it. So stay tuned.
Thanks for watching the 25th video in our Logic Gate series. If you found this guide to building XOR and XNOR gates using only NOR gates helpful, don't forget to like, share and subscribe for more lessons. Hit the bell icon to stay updated with our latest videos, check out the full playlist to master Logic Gates, and follow us on Instagram. I will see you in the next video. Until then, keep learning and stay curious. Bye bye.